to another session of Concept at Fingertips. This is Vidya, Physics faculty. Today, let's see the topic magnetic field due to a current through a circular loop. So in the last session, we have seen the magnetic field produced by a straight current carrying conductor, and we can use right hand thumb rule to find out the direction of that magnetic field. So in this session, we are going to see the magnetic field by a circular loop. So in the figure, there is a circular loop given, and let's imagine this is the circular loop. So let's imagine that a current I is passing through this loop in this direction. So this circular loop can be considered as made up of lots of straight conductors like that. So what we can do is we can actually place our right hand along the small conductors and find out the direction of the magnetic field. So if we are considering this particular straight conductor portion, and you are placing your right hand here and your fingers will curl in the direction of the magnetic field. So what we can see is that wherever in this loop we are placing our right hand, at the center of the loop, all of these contribute the magnetic field in a particular direction, in a single direction. So that can be seen from this right side picture. So this is the coil, and here it is given as plus and minus, so that the current is entering here and it is leaving from this side. And we can see that each section will create magnetic field in concentric circles, because we have seen that in the previous video that any long straight conductor will produce a magnetic field in concentric circles around it. So the magnetic field produced by this particular conductor will be in concentric circles, and it will be anti-clockwise field if the current is going like that. And another thing that we have already seen is that the concentric circles keep on increasing their radius as we go far away from the conductor. So by the time we reach the center, of the coil, what happens is that the circles will be very big, so that the arc the circles are making, they look like straight lines. So since all the sections of this conductor, wherever we take, the magnetic field will reinforce the field in the center. So it looks like the field is entering from one side. See, at this side, the field is entering, and it is leaving out of the coil from the other side. So wherever the field is entering, that is the south pole, that acts as the south pole, and wherever the field is leaving out of the coil, that acts as the north pole. Now, what if we increase the number of turns of the coil? So if you increase the number of turns of the coil, if there are n number of turns, then in each turn, current will be flowing in the same direction. Each turn will have current in the same direction. which will produce a magnetic field in the same direction. In same directions. In other words, what we can say is the magnetic field produced by all these turns will add up, so that the magnetic field produced by n turns will be equal to n times magnetic field produced by individual. Where B represents the symbol for magnetic field. I hope the topic is clear. We'll meet you in another session with another topic. Thank you.